Module 2.7. The first is coffer dam. Coffer dam is a watertight enclosure from which water is to pump expose the bottom of the body of the water below the waterline of the ship. This is a temporary bullet across the body of the water and constructed to allow the water to pump out of the enclosed area. And this is used to order to allow a dry working environment. Once the coffer dam is in place, crew are able to do things like excavation, repairs, and viewing. The next one is fuel tank. A fuel tank is a safety carrier from flammable fluids. The storage tank for fuel may be so called. The terms of typically applied to the part of an engine system, which the fuel is stored and propelled fuel pump or release the pressurized gas into the engine. This will act as the reservoir for the vehicle's fuel. The tank has an electric trigger but conveys information certain the amount of fuel to the gas gauge. And the next is duct keel. Is the plated buoy. Keels allow passage right forward. It provides additional buoyancy together with a throat passageway for cables and pipelines running in the fore and aft direction. Fourth one is peak tank. It is tank which of the bow or stern end of the ship, and its low in the ship usually keep empty the dry but sometimes used to carry portable water. Fifth one is the double bottom tank. Double bottom tank is a ship whose design from constructions method where the bottom is the ship has two complete layers of watertight whole surface, one outer layer forming the normal hull of the ship, and second inner hull which is somewhat higher on the ship, which redundant barrier. That's all my report in 2.7. Bye, sir.
Everyone, my name is Claros, and today I will be discussing about the inspection interval of ballast tanks. Now, before I move on to my topic, I would like to add about the corrosion of ballast tanks. So the extent of corrosion inside the surface should be noted. The localized corrosion should be marked appropriately. If the corrosion waste of the tank surface exceeds 75% of the allowable margin, repairs such as renewal of all structural to be carried out. So inspection interval. Tank inspection intervals to be followed on board as per vessel's planned maintenance system. In principle, the interval should be followed. Water ballast tanks, tankers, and gas carriers at least once every 12 months. Water ballast tanks, container ships at least once every 12 months. Freshwater tanks at least once every year. Void spaces or coffer dam at least once a year. Cargo holds of container at least 30 months. Fuel oil tanks at least once every 30 months. Double hull tanks in engine room at least once every 60 months. Cargo oils of tankers and liquefied gas carriers at least once every 30 months. Hold space liquefied gas carriers at least once every 30 months. Now that we know about the inspection interval of each ballast tanks, let us move on to the ballast tank protection. The ballast tank is filled with seawater, which is highly corrosive in nature. When the tank is empty, the dampened atmosphere will also increase the corrosion attack on the ballast tank surface. Corrosion is a major problem on ships. Following methods are used for protection against corrosion. So there are three types of protection against corrosion. The first one is tank coating. Coating in the tank surface is the most common protection system used on the ship. The advantage of the coating is that it protects the entire tank at a time if the right quality of coating is applied. The ballast tank can work without any problem for a long period. It is that layer of the coating which protects the seawater to come into contact with the steel of the tank. The coating dry film thickness can be as thin as 300 microns. The most common type of coating used is heavy-duty dual-component epoxy coating. Second is anode. The use of sacrificial anode is very popular inside the tanks to control the corrosion. Zinc, aluminum, and their alloys with metals such as tin are popular choice of anodes used on board. Magnesium anodes are not to be used in the ship ballast tank's water as they tend to generate hydrogen while in operation, which can have deleterious effects on some ballast tank coatings. Aluminum anodes are not used on oil tankers as they are prone to spark hazard if dropped with significant heights. The third and the last is controlled atmosphere. If the atmosphere of the ballast tank can be controlled to reduce the oxygen content, the corrosion rate decreases drastically. This system, known as oxygen stripping, which is done by introducing inert gas to maintain the oxygen level in the tank below 4%. This system is used with the tank protective coating and even the anodes fitted tanks to extend the life of sacrificial anodes. It reduces corrosion to as much as 84%. So that's all for our report on modules 2.7 and 2.8, which is about the different parts of the ballast tanks that are susceptible to corrosion and the inspection interval of each ballast tank. So I hope you've learned something, and as always, God bless.